Hi guys, welcome to today's tutorial. We'll be looking at sketching parabolas. There will be a few things or important things that we'll be looking at today. Whenever we're sketching a parabola, there will be about 4 things that we need to do. We need to plot the y-intercept, and I'll go through all of these as well in depth. We need to plot the x-intercept or intercepts. That's if there are any, of course. We want to look at drawing our axis of symmetry, can be referred to as the AOS for obvious reasons. And fourth, locating the turning point. And the turning point can be a maximum or a minimum turning point. And all I mean by that, if it's a maximum turning point, it means it's up high. If it's a minimum turning point, okay, it's down low. And I guess the other thing we need to also recognize, which is I'll put as a note there, whether it is a positive or it is a negative parabola as well. Okay, so these are things that we'll be covering in today's lesson, particularly things like the x-intercepts, which is highly, I guess, relies upon solving quadratic equations. If you don't know how to solve a quadratic equation, or you're not very good at solving quadratic equation, I suggest you go back and look at the lesson on solving quadratic equations, because that is very, very important. Okay, so let's have a look at a few things to start with. I'm going to look at an example, e.g. 1, and I'm going to ask you to sketch the graph of y is equal to x squared. We'll do minus 4x, and look at doing, we'll do minus 5. Okay, so I said there are those 4 pieces of information. So the very first of all is knowing what the y-intercept is going to be. Now, for most parts, guys, you can simply look at this equation and straight away say that the y-intercept is minus 5. Okay, it's like doing a straight line. That plus number or that minus number at the end of it is your y-intercept. It tells me, and if I do just a very brief sketch there of my x and y axes, that it's going to be cutting it at negative 1, 2, 3, 4, and 5. It's going to be cutting it down at that point there. Why is that going to happen? Well, theoretically, well, not theoretically, what we actually are doing there, in order to find the y-intercept, we let x equal 0, because that point there is the point where x is equal to 0. And if I want to find out what my y-coordinate is when x equals 0, we simply substitute that into the equation. Y is equal to 0 squared minus 4 times 0 minus 5, which obviously 0 take away 0, take away 5, is left with y equals negative 5. Okay, so again, I substituted the point x equals 0, because that's my where x equals 0, y equals negative 5. So that's the first thing. But again, you don't really need to do the substitution of x equals 0 in there, because you should be able to look at it straight away and say what it's going to be. If there is no y-intercept, then obviously it's going to be 0. Okay, that's the first thing. Now, the second thing, which is often going to be the most important and can be the most challenging, is finding your x-intercepts or intercepts. Now, sometimes you will have 2 intercepts. Sometimes you'll only have 1 intercept. And there occasionally you will have no intercepts. Okay? And what that sort of means, basically, if you have 2 intercepts, it means it's going to cut it the x-axis in 2 places. If you have 1 intercept, means it sits nicely upon that x-axis and just touches it in at one point, and no intercept means it doesn't cut it at all. Okay, so again, you can see there it cuts it in two places. Here it cuts it in one spot. Here it doesn't cut it at all. So how do you find the x-intercept? Well, like when we find the y-intercept, we let x equal 0. On this line here, which is where my x-intercept is going to be, that's the point y is equal to 0. Because obviously if I go up, y is positive, y is negative, but that line y equals 0. So what we're actually going to do, we're going to substitute y equals 0 into my equation. That leaves me with 0 is equal to x squared minus 4x minus 5. Now, what you now might recognize is that that is a quadratic equation. Okay, and that's what you've created, a quadratic equation. And when we went through the quadratic equations, we spoke about the solutions being the roots of a parabola, or where they cut the x-axis. So that's exactly what we're doing. Again, you know, they're going to be about the x values, the roots of this equation. So we want to solve it. So I'm just going to rewrite it and put x squared minus 4x minus 5 equals 0, just because that's how you probably usually used to it. I'm going to solve it by whatever means necessary. Now, if you want to solve it by factorizing or by using the quadratic formula, which we just learned about, then that's up to you. Probably if you can do it by factorizing, it's going to be quicker. In this case, I look at it, 5 and 1 can make minus 4, so it's actually going to be x minus 5. Then we're going to have x plus 1 equals 0. So I'm going to get the solutions of x is equal to 5 or x is equal to negative 1. Okay, so I'll go back to my graph now. I'm going to put the negative 1 there, then 1, 2, 3, 4, 5. And on that graph, I'm going to plot my 2 points, negative 1 and negative 5. And you can start to see that my parabola is going to be coming down in that type of shape. I don't know how far. And I guess that's a very big problem. I mean, if I was just doing a really a basic sketch, I'd probably just draw it like that. Okay, but I've said that there are two other things I would like you to find. The third thing was our axis of symmetry. Now, what does your axis of symmetry mean? Well, hopefully you remember that an axis of symmetry is where, you know, if I have my parabola like this, okay, the axis of symmetry is where it cuts that parabola directly in half so it can fold perfectly. In that case, my axis of symmetry would be straight down the middle here. There are two ways to do it. The easiest way is probably a line of sight. And recognizing if that's 5 and that's minus 1, then I simply need to count in halfway. For example, okay, if I go 1 in there and there, I go another one there and there, and then all of a sudden this line here is halfway between the negative 1 and positive 5, which is in fact my line of x equals 2. Don't need to write x equals 2, but I'm just going to write up there so you can see. So you can see that's going to be my line of symmetry, my axis of symmetry. So we know that that's where the turning point is going to be somewhere. So again, you can see if I, I guess if I sketch it like this, it's going to be turning somewhere around there. Again, it's a bit hard to sketch it using this, but you can sort of see what I mean by that. And you can see that my turning point here, which will be a minimum turning point, lies on that axis of symmetry. So line of sight, I'll put that there, line of sight is one way of finding it. The other way is if you're not sure of what it's going to be, particularly if you're dealing with decimals or fractions, you can use the formula x is equal to negative b over 2a, which is a really good formula to remember. Remembering that your parabola is in the form of ax squared plus bx plus c, okay, where a is in the front of the x squared, that's 1. The b is in front of the x, which is the negative 4, and the c is the negative 5. So if I looked at that there, I've got negative 4, so it becomes a positive 4, over 2 times 1 is 2. 4 divided by 2 is 2. So it means my axis of symmetry is line x equals 2. And look at that. That's what we had there. So certainly you can do it by the formula. And it's a good formula to remember. Now the very last thing, which is often the one that most people struggle with, but we shouldn't. okay? And that is finding what the actual turning point is. At the moment, I've sort of just sketched it in, but I don't know how far it goes down. So how do I find this? Well, we certainly know that the turning point lies on that line x equals 2. So when x equals 2, what does y equal? That's a question we need to ask ourselves. We've got our formula here, so why don't we just put x equals 2 into this formula? Because if x equals 2, then that will simply tell me what y is equal to. So for our fourth one, and we call this the turning point, we just sub in x, okay? So again, we're going to put y is equal to 2 squared minus 4 times 2, and then minus the 5. So obviously 2 squared is 4, minus 8 minus 5. It should be a negative number because obviously it's below 0 there. So 4 minus 8 is negative 4, minus 5 is negative 9. So this is the point 2 comma negative 9. And often I write that turning point in so you can see it there. Now obviously if you were using a proper scale here, you could certainly show that that point where there was negative 9. Okay, so quickly just to refresh there. Okay, we've got my y-intercept, which is that point there. That was from the minus 5. We've got my 2x intercepts by solving that equation, quadratic equation, and then putting my 2x intercepts there. We then found my axis of symmetry by, we did line of sight, but you could also do the equation. And last of all, once you found out what your axis of symmetry is going to be, your x value, chuck it back into the original equation of the line or the curve, and then that will tell you what the y value is, and you can chuck that on there as well. So 4 really important pieces of information that's going to help you to construct that. Okay, so what I'm going to do, I'm going to draw another example here, and I want you to pause this, and then I want you to have a go at sketching this parabola. So sketch the parabola. Y is equal to, we'll do x squared, we'll do plus, actually no, we'll do minus 4x plus 3. Okay, so I want you to pause it, have a quick crack at this question, and then go ahead and see if you're correct. Okay, I'll see you on the other side. Welcome back, guys. Hopefully you've had a good crack at this, remembering the 4 pieces of information we want to find, we want to draw on. We want to draw on the y-intercept, we want to draw on the x-intercept or interceptor, we want to draw on the axis of symmetry, and we want to draw on our turning point, whether it be a maximum or a minimum turning point. So my 4 pieces of information that we need to find in order to graph this. What I might do, I might find all these pieces of information without even drawing it first, and then draw it on finally. And you can certainly do that, or you can draw it as you go. It's up to you. Okay, so for my y-intercept, we know the y-intercept is plus 3. So I'm going to put here y is equal to 3. My x-intercepts, I'm going to put x squared minus 4x plus 3 equals 0. I'm now going to solve it. That's going to be x minus 3, then x plus 1. Actually, sorry, my bad. X minus 3, x minus 1, because it needs to be a positive 3, equals 0. So x equals positive 3, or x equals positive 1. My axis of symmetry, I'm going to use the formula, negative b over 2a. So x is equal to, well, negative 4 makes positive 4 over 2 times 1 is 2. So x is equal to 2. That's my axis of symmetry. And the last one there is my turning point, which is going to be, in this case, well, when x equals 2, I'm going to find what y is equal to. So y equals 2 squared minus 4 times 2 plus 3, so equals 4 minus 8 plus 3. Well, 4 minus 8 is minus 4, minus 4 plus 3 is minus 7. This is going to be very similar to the one we just did. Okay, so I've now found all my pieces of information. as you can see there. Look, you most welcome to do it that way and then draw it, or you can draw it as you go along. So obviously my diagram is not going to be perfect, as you can already see. That's on a bit of a slant, so my apologies. A bit hard to do it when I'm doing it on this little tablet thing. Okay, so we know we want to have my x values are 1 and 3. So 1, 2, 3. Making sure when you're doing your axes, I know we're sketching it, but make sure your x-axis values are all the same width apart, and then make sure your y values are all the same width apart. So my other values for y, make sure it goes up to 3. So 1, 2, and 3, and down to -7. 1, 2, 3, 4, 5, 6, and 7. Okay, so let's now start putting on some information. Okay, my y-intercept is +3. My x-intercepts are 3 and 1. I've got my axis of symmetry, which, well, we can see a line of sight anyway, is clearly 2. So that's my axis of symmetry. Not very straight there again. Okay, I'm just going to put there x equals 2. And then my last piece of information is my turning point, which is -7, which lies on that line there. Okay, which is 2, -7. Which again, I like putting that turning point on there. And now it's just a matter of sketching that as best as you can. And again, it's going to be a little bit hard for me here. That's really not very nice, is it? Yeah, it's much harder using this tablet thing. Okay, but you can sort of see where I'm going with that. So again, you can see my points there. Let's do it in red so you can see it. My y-intercept, my x-intercepts, my turning point, and my axis of symmetry. So 4 pieces of information there that are exceptionally important. And again, I'd probably finish off by doing y is equal to x squared minus 4x plus 3 and writing it that way. Look, I'm going to do one more question. I just want to show you something. A few people do freak out when they get questions like this. So I certainly do want to show it to you just in case you cop something like this in the exam. I don't want you to freak out about it, and it's just the way that the actual equation, I guess, is written. So I'm going to ask you to, for EG3, ask you to sketch the graph of y is equal to -x squared -2x plus 3. Now you might remember back to when we were doing this, when we were looking at our solving, that we don't like to have the negative with the x squared. So when we go through the y-intercept, which I'll do that in a moment, so the x-intercepts, that's where it gets hard. That's the only reason why this is more challenging. But also, you know, it's a negative x squared, which means that your parabola is going to be upside down. It's going to be an unhappy person. So let's go through my 4 pieces of information. So first of all, let's find the y-intercept. Okay, so I'm going to put my y-intercept is simply just 3. Done. My second thing, we want to find the x-intercepts. Now this is where it's going to be a bit more challenging. This is why it's only reason why this is a little bit more challenging. So I'm going to put -x squared minus 2x plus 3 equals 0. Now obviously if you chuck that into the quadratic formula, you know what? That's pretty dead easy. Okay, that way you can leave the negative there, and it's going to be fine. But if you want to factorize it, I'd take the negative out first of all, which obviously is then going to change the signs of everything inside there. I can now factorize it. That's going to be 3 and 1, so it's going to be 3 take away 1, so minus x plus 3 x take away 1 equals 0, which I now get x equals -3 and x equals 1. Notice that minus at the front, it has no bearing on these at all. Okay, it's as if it's not even there. So if you're doing this by factorizing, okay, just don't make. Some people like to bring that minus back in, change this to a plus and a minus, and it just confuses people. If that's you, if you are going to get confused, then perhaps maybe using the quadratic formula is going to be your best bet. Okay, that's up to you. That's the only reason why this is a bit more challenging. The rest of it's dead easy. Okay, so you've got your axis of symmetry. Again, you can do this by line of sight if you wish. I'm going to do it by using the formula. So x equals negative b over 2a. So x equals negative b, which is positive 2, over 2 times negative 1, which is 2 over negative 2, which equals negative 1. Then I've got my very last piece of information, which is going to be my turning point. I'm going to put TP there. Okay, I'm going to put when x equals negative 1, y is equal to, negative 1 squared minus 2 negative 1 plus 3. To be honest, guys, if you just put that left to right in the calculator, you'll get the right answer. I suggest you do that. Otherwise, you could get a little bit misled. If I do it by hand, though, I square negative 1, I get positive 1. Remember, there is a negative at the front, though. Negative 2 times negative 1 is positive 2 plus 3. 3 plus 2 is 5, minus 1 is 4. Okay, so my turning point there is going to be the point of negative 1 and positive 4. So I can now then put all that information onto my graph. Again, I'm not going to be very particular about this. Okay, but I would like you to be. So my y value needs to go up to 4. 1, 2, 3, and 4. That's my, that's my there. So that's just so I can see that there. So what's my y-intercept is 3. So I'm going to put it in red. So my y-intercept is there. Okay, my x-intercepts are going to be negative 3 and positive 1. So 1, and then 1, 2, 3. Okay, so I'm going to put that there. Negative 3 and positive 1, which you can now see that's where it's going to be obviously the negative or the unhappy face one. I've got to put my negative 1 line in there. That's my axis of symmetry. Okay, x equals negative 1, which obviously it's going to lie upon that, so it's probably going to be there. Negative 1, positive 4. There we go. And I can now sketch it on there nicely. And it's going to sort of look like that. Unhappy face. Okay, and that's the graph of y is equal to minus x squared minus 2x plus 3. All right, I know this has been a pretty long lesson, guys, so I apologize for that. The good thing is that these questions do not change. Okay, if they ask you to sketch it, just remember your 4 pieces of information. So number 1, find your y-intercept. Number 2, find your x-intercepts. I'll put that by solving the equation. Number 3, find your axis of symmetry by x equals negative b over 2a. And 4, find your turning point, whether you're maximum or a minimum, okay, by subbing in x into your equation. Okay, then you should have a very nice little parabola and you're going to get full marks. Have a great day, guys. I hope this was helpful.